Good afternoon. Good afternoon. Hello. Good afternoon. I want to first of all suggest that as you finish your meal, you move to the front, because then you'll be able to see the screen and hear the speaker much better. The room is not perfect for this, but it's a lovely room, and Tom just told me that it used to be the library for Milwaukee Downer College, so I think it's very appropriate that we're here. But the acoustics are not ideal, so I think you'll be wanting, which is why I had to shout at you, I think you'll be wanting to come forward as soon as I'm done with my introduction. I want to welcome you to the inaugural lecture in a series that is being sponsored by SOAS's Information Organization Research Group. And we're very, very pleased to have Jane Greenberg here for this first lecture. Jane's a professor at the School of Information and Library Science at Chapel Hill, University of North Carolina, Chapel Hill. She's also the director of the Metadata Research Center there. And probably most exciting, at the moment at least, is that she just won a Jesse Shiro Award for the Research Roundtable of the American Library Association. So, with that, I think I'll just turn it over to Jane, but while we're getting ready, please move up.
Thank you, Hope. Can you folks hear me? I'm projecting okay? If I fade, let me know, and do feel free to move up. I bite, and I actually have a little video with music, so if you come closer, you can hear it. But it really is a pleasure to be here. I've been here since Tuesday when I went to the Harley-Davidson Museum, and really have had a very enjoyable time. I've enjoyed meeting people, seeing some old friends, mentors, and making new friends. So it's really been a great visit, and I'm really pleased to be here now and have a chance to share some research and development work that I've been doing. And I'm going to speak about the HIVE project, which stands for Helping Interdisciplinary Vocabulary Engineering. And the project is an approach and a model to vocabulary integration. So to give you a little bit of an overview of what I'm going to present, I want to first, I'm left-handed and my slides are over there, so I may have to move around a little bit here. But I want to introduce the project and talk about the motivation underlying the project. Then I'll move on to the goals and the status, what we've been doing, the design of the project. Then we have done some evaluation, pretty preliminary evaluation on how users are working with the system and the performance of this vocabulary integration application. So I'll share a little bit of those highlights, talk about some of the challenges we've had. It's a team project, and there's aspects there and just in terms of any large-scale project, and wrap up with a few concluding remarks. So, as I said, HIVE is a model and approach, and it's developed for vocabulary integration. And the title is very appropriate, not just the acronym, not just the Helping Interdisciplinary Vocabulary Engineering, but the idea of a hive. If you can think about a bee going out to different vocabularies and bringing in the correct concepts, that's what we're talking about in terms of metadata generation. And in this case, subject metadata generation, when one controlled vocabulary is not sufficient. The idea is to integrate and pull from different vocabularies. So in this project, in the HIVE project, we had vocabulary partners, and for some of you, those acronyms on the far left are probably familiar. LCSH, Library of Congress Subject Headings, NBII, which is the National Biological Infrastructure, Thesaurus, Information Infrastructure Thesaurus, TGN, Thesaurus of Geographic Names. And well, MESH is actually not an official partner, but we are toying with it. So the idea of pooling concepts from different vocabularies at the time of creating metadata is not new, but what is exciting now in our information infrastructure is developments that are coming out of the World Wide Web, and in our case, SCOTS, which stands for Simple Knowledge Organization Systems, in a way of encoding and allowing for dynamic integration of vocabularies. And this project was approached to address cost issues with wanting to use multiple vocabularies, usability issues, and interoperability issues. So it's very costly in terms of human resource and financial resources, to go and look at each vocabulary separately at the time of indexing if you wanted to use multiple vocabularies. Vocabularies are developed in silos, they're not always interoperable, and in terms of usability, lots of users don't even know that controlled vocabularies underlie information systems. So the idea of making them more usable. I'll come back to some of this, but this is a little bit of the overlay of the HIVE project. So I've said a little bit about motivation, but I want to dig down a little more deeply. And I know this slide is a crowded slide, but it is the impetus for the project and our ground, which is working on a project called the Dryad Repository Project. And the Dryad Repository Project is for research data underlying published research in the field of evolutionary biology. It's a project that was initiated through the NESCENT, which is the National Evolutionary Synthesis Center, located in Durham, and my Metadata Research Center. And evolutionary biology is a very interdisciplinary field. I have some of the subdisciplines written up there: ecology, paleontology, population genetics, physiology, plant systemics, and it goes on and on. There is no one evolutionary biology controlled vocabulary. And the idea of creating one to index the data in a repository is just prohibitively expensive. So from the beginning, as this repository was being initiated, we recognized that there were vocabularies out there, and each had something valuable, and we wanted to be able to pull from them dynamically at the time of creating metadata. So evolutionary biology, I have this great picture of Darwin. Last year, I still can't take off my slides, last year was the 200th anniversary of Darwin's birth and 150th anniversary of origin of the species. So think, survival of the fittest. But also what's happening in the Dryad project, the reason this repository is being built is science, data underlying science publication, a lot of it is orphaned. It doesn't have a place to go. And evolutionary biologists heavily depend on data from other scientists. They're studying the evolution of some kind of species over time. So if it's a biologist that's working with gene sequences, they may be able to put their data in GenBank. Or if they have a morphological tree, there's a system called TreeBase. But a lot of data is orphaned and it's lost. And we did do some studying, and I'm not going to give you all the statistics behind it, but we looked at a sample of, we had 400 evolutionary biologists. We asked them about their data sharing practices and archiving practices and so forth. And we found out that 48% of them did research when we were surveying them, had research based on data from somebody else. But 78% of them had not deposited their own data. So there's a mismatch. They're depending on data for their research, but it's not found. And so that's the rationale underlying the reason to build the Dryad repository. And that's an NSF-sponsored project, but we also need vocabulary as part of it. And so we continued on with that. These are just some of the partner journals that are in the Dryad repository. So right now, to publish in these journals, they are encouraging deposition, and actually it's happening. We are a repository that has data in it, and eventually the journals do say that it's going to be a requirement of being published in these journals. I'm not involved. I mean, I sit sometimes in these management board meetings. I don't know if they'll really be able to enforce it, but it is happening, and it's quite exciting. And the journals themselves have signed what's called a joint data archiving policy. It's very interesting, the field of evolutionary biology, how folks have come together on this. So back to the vocabulary needs, though, given that the field is so interdisciplinary. We did a study as this project launched, and we took 5 of the partner journals and we looked at publications, the whole run of articles in 5 of the department journals, and we took the keywords and we mapped them, we searched them basically, in 10 different vocabularies that we thought might be useful for indexing data in Dryad. And some of the vocabularies were the MBII, thesaurus, LCSH, Eric thesaurus. We looked up methods used, research methods amongst evolutionary biologists, the gene ontology, and so 10 different vocabularies. We also, before we did the searching, we organized the sample of keywords. We had about 600 keywords. We organized them into facets. So taxon was one facet, scientific name, geographic area where the research was done, the time period, genotype, phenotype, and research method. And we worked with the scientists, the folks from the Metadata Research Center, and the scientists who are active at NESID, and to create these facets. And then we went and we basically searched up these terms and these vocabularies to see how good some of them actually would be. And what we found, this is just some of the results, for the terms that were classified as topical, we found that there was exact matches for 25% of them in the MBII thesaurus and 18% match in MESH. And then we looked up terms that we looked up in the Library of Congress subject heading. We looked up topical terms, research method, and taxon, so there was a larger sample. And we found some, quarter percentage match, basically 22% found exact match, and then we had partial matches. And so we have larger amounts of data, but we use this to justify a grant that we put in for the need to create a separate tool to lay on top of the Dryad repository that would allow for the dynamic integration of vocabularies at the time of indexing. So, the conclusion to this was that no one vocabulary, it just illustrated, no one vocabulary is sufficient for indexing in evolutionary biology, but there's a little piece of multiple vocabularies that seems good. So, we put the researchers from the Metadata Research Center and NESID, the Synthesis Center, got together. We put in a proposal to IMLS and on HIVE, and the 3 sort of overriding challenges that I mentioned at the beginning, cost, interoperability, and usability, were what we wanted to address, not only for HIVE, for Dryad, but we also couched it in that this problem is not unique to evolutionary biologists. There are many fields that are interdisciplinary that could benefit from the idea of dynamic integration. And people have spoken about this for a long time. There are other people who have tried things, but as I said, the technological infrastructure, things like XML and particularly SCOS, are new enough that not many people have tried them. So the time is right. Also, so thinking about it not just for our repository, but the larger library, museum, and archival community was important, particularly for people in the Metadata Research Center. So, HIVE is being developed to address these challenges of integrating vocabulary terms from multiple vocabulary sources to provide efficient, affordable, interoperable access to multiple vocabularies at the time of metadata generation, and it's a demonstration project to show that this can be done, and that perhaps other interdisciplinary initiatives could take our model and approach, and everything we're doing is open source, and share our code, our library of tools, and create their own HIVE. So we have a joke on our team. We like to say, "to HIVE" is a verb. So feel free to use that. But the HIVE project has 3 goals. Building HIVE, which is the vocabulary preparation, meaning encoding the vocabulary in SCOS, XML, SCOS encoding, and developing the server. And this is really system development work. Sharing HIVE, which is continuing education. We have plans to do workshops to empower information professionals and teach them about SCOS and coding and how we went about teaching our machine to understand the HIVE process. There's a little bit of machine learning going on behind the scenes with our vocabularies, so we've had to feed documents into it, and then evaluating HIVE, which we have plans for more formal evaluations as the project develops, but we already have been doing some preliminary evaluations, which I'll share. So 3 goals, 3 overriding phases. I guess the 3 phases of HIVE. So we talked about them: building, sharing, and developing. So we have 3 formal vocabulary partners. The Library of Congress, we're using LCSH, the Getty, and we're using their TGN vocabulary for geographic names, and then the USGS, that agency maintains the MBII thesaurus. We have a large advisory board, and some of these people may look familiar to folks, especially who are in the area of organizing information. And really great advisory board folks giving us feedback along the way. And then, as I said, this phase of sharing HIVE has this educational aspect of empowering information professionals for workshops. And so we actually have already identified partners who will help us host these workshops. So, for instance, Columbia University is one place. We have a partner in Spain, and we're hopeful that maybe the workshops will take off and we'll be able to offer them in other places as the project develops, to share how we've developed this project. So HIVE is constructed at this point. It works. And actually, I don't know how much time I'll have, but you can go and fool with the system. It's up and it's operational. You can upload documents and experiment with it. But right now, it stores millions of concepts and makes them accessible through this HTTP protocol. And I'm not a system designer. I have a great programmer working. We have a great programmer working on the project who does all the RDF and SCOSing and so forth. We have the HIVE has 2 modules to it. So one is HIVE Core, which is the storage and management of the vocabularies that are in SCOS, and then HIVE Web, which is sort of the access part where users interact with it. What's happening in HIVE Core is interesting. We have 2 levels of HIVE. We call one Smart HIVE and one HIVE Simple. And as I said, there's a little bit of machine learning that's been happening behind the scenes. So initially, we thought that we would just put in the vocabularies into HIVE and code them all into SCOS, and that we would do a little processing at the time of metadata generation, we would pull out keywords from publications where there's data being represented, and just do straight term matching in these vocabularies. But the noise, the amount of extra terms that came back was difficult. It was not very good. So we have the person that's doing this programming, his name is Jose Perez Aguera, who actually has a doctorate in information science and computer science. I couldn't have asked for a better colleague to work with. Just a really good researcher, really good programmer, and has a background in information retrieval. And so he has put in a machine learning algorithm based on natural language processing and term frequency, and has really done a nice job and cut down on the noise that we have at the time of indexing. So we've got some IR activities going on beyond just straight term matching. And it takes a little longer in the processing, but what we found in some of our testing, whether we do simple HIVE, which is quicker and brings back more irrelevant terms, or the Smart HIVE, which takes a little longer and brings back much more precise terms for assigning to your document, people complain about the time regardless. So, but we're working on things right now where some parallel processing is being implemented. And as I said, I'm not really a systems person, but we are trying to address the efficiency issue. So if you experiment with HIVE, it works, but you may have to be a little patient. So, and the Smart HIVE KIA is the automatic indexing tool of Maui. That might mean something to some folks. And then the concept retrieval using Lucene. So, I'm not sure how many of you have seen a SCOS concept, but since I keep mentioning it, and XML, the concept is with hope. I guess I didn't mention up here, in the building HIVE, as I said, there's the library information science, the library, archives, and museum community that we thought about, the bigger issue, but the Dryad repository, to test HIVE and Dryad, we picked two groups, and so one is primate life histories working group, and the other is the wood anatomy and wood density working group. I'm sure that doesn't mean too much to you, but these are evolutionary biologists, and they study these specific areas, and so to actually do some testing, we picked different groups to focus in on, and in terms of the biologists. All right, so HIVE exists, and there are three parts to it: the home, the concept browser, and the indexing application. And I'm not sure how well you can see it back there. In the back, I mean, you probably can read these top tabs, I hope, but there are chairs up here, so if you want to see it, come on up. But what this is just the initial way you can search for a let's see, home. You can select your vocabularies and put in your concept here. So we have right now, in this slide, I mean, we have some other vocabularies, but right now in this slide we're showing the agribok, which is the agriculture thesaurus. They're not really official partners. I put them on the slide before because we've been using their vocabulary too, which was already available in SCOS, and I need to communicate with them. LCSH and NBII, so you could type your concept in. And then here is the concept browser, where, so wood is typed in and you're searching it in the NBII, but you also, at the time of doing it, you actually you said you're going to search NBII and LCSH and agribok. And so what you're getting over in this box is Library of Congress, the word wood in Library of Congress, and also in agribok. And then you could click on it here, and what you're seeing are basic thesaurial relationships. So you've got preferred label, URI, alternative label, broader term, narrow term, related term. So URI, folks, that's all leading towards what semantic web, perhaps, link data. And then for people that wanted to view a SCOS, they could view it. SCOS, what it looks like. So, and this is what we've been testing with users, both. We've just done really a little bit of testing, mainly in information organization classes with students, but we have had librarians and some scientists, very small sample scientists, 4 scientists in a formal study, experiment with this, where they would upload their abstract for their published research for the data that they're going to be submitting to the Dryad repository. So I guess I didn't mention that with this Dryad repository, that the idea is to generate the metadata automatically as much as possible when the scientists are putting their data in as part of the publication process, and also to harness the intellect of the scientist first and get them to create metadata as well, and save the professional for quality control and things that, authority control, things that need help. But by having something like this, where the vocabulary is pulled dynamically, we can hopefully get them to use controlled vocabulary in a better way. So what they can do is they can select vocabularies, they can upload their you can upload a full document if you experiment with it, or upload their abstract for their published research, which would then serve as a source for terminology for their data. Or you can even enter a URL. So we've tried some things there, so if you wanted to catalog your lab or something like that. So that's what's happening there in the indexing. And here is one of the versions we've had in terms of what it looks like. So this is an article, and I title really bothers me. The endocrinology of pregnancy and fetal loss in wild baboons, but it is about baboons. And the result here is this tag cloud. And so the colors represent the vocabulary, and the size represents the term frequency. And so there's some things that are relevant and some things are not. So for instance, Baboon Creek, which comes from the Library of Congress subject headings, is not really a very good term. But estrogens from MESH is a good term. And the idea is for the scientists to then click on the ones that are good to assign to represent their data set. What's been interesting about the tag cloud is, at first, except for me, the folks, the library information science folks on our research team, and the scientists just really didn't like it. It didn't make sense to them. They said it was a misuse of the tag cloud. And so we then had another version where everything is flat, and now we've actually gone back to thinking about this again. So maybe two projects and how people are talking. So you'll see another example of that. So I want to give you a scenario in terms of Dryad and how we envision it would work. Right now, as I said, it's available for testing, but we haven't implemented into the Dryad repository. So how am I doing time-wise? Okay, great. Excellent. So, meet Amy. Amy's name is a botanist, and like every good botanist, she publishes her research, and these are two of our partner journals. And she collects data and doesn't have a place for all of her data. So she's the product of the orphan data community. But Dryad exists now, and she should put her data into Dryad at the time she publishes. So she deposits her data in Dryad, we hope. She's good. Amy actually does. Amy was a scholar at Nescent. She's now at Purdue University, and she's the person who uploads her data. This is the Dryad repository, and it's built in DSpace. And here is an article that she has authored with the abstract. And here you can see that she has an Excel spreadsheet of data that underlies this published research. And there's some interesting metadata things happening in Dryad where we take the bibliographic metadata and automatically populate it down to represent a data package, and then also automatically populate it down to represent individual data files. In this case, there's only one data file, but we have things in Dryad that have 10, 15, multiple data files. And think about some of your own published research. Each table that you have could be represented by a spreadsheet or some kind of data file. So anyhow, this is what it looks like in Dryad. But if she's going to work with HIVE, she would take that abstract and upload it, or you can actually, there's another version where you can actually cut and paste the text in to do the automatic processing. So here's this abstract again. And here are the results. So this is one of those results where the tag cloud is presented, where everything's equal. And so let's see. Her review and synthesis, and it's toward worldwide with economic spectrum and ecology letters. And so some of these concepts are relevant and some aren't. Let's see. Arabian identity copies and density, which is part of wood density, is probably somewhat relevant. And so it's the same idea where you could click on relevant concepts. And you don't have the whole abstract there, and neither do I, but this is the scenario. And I showed you already the tag cloud. So curious. I really, afterwards when we have discussion, always want to hear from people about this versus that, where you have the text the size of relevance, because we're having, I don't want to say fighting, but passionate discussions in our team about that. So, actually, are there any questions right now? Because I was going to go on to some that where we've done a little bit of evaluation on the system. Yeah? Yes.
What was that?
That's a programming toolkit that we've used to make it web accessible. Google makes it, it's programming. Yes?
And they're all the network generated by the KEA.
Kia. Yes, Kia++, which is the automatic indexing. Part of that and part of whatever that Lucene and other things after it. And so, yeah. So. I'm going to show you one other thing before I go on to talking about the evaluation. And this will just, now that you've saw a little bit about it, so thinking about, there's three parts: the regular home page, the concept browser, and the indexer. This will just make sure you're awake. I hope the sound works. Oh, oops, sorry. I think I clicked the wrong thing. There we go. So this is just taking you through it a little bit more. Showing how you can use it. You can hear the music in the back. You can hear it up here. Onto your desktop, you're uploading a PDF in this case. It's processing, and there are your results. So, yeah, that's accessible too on the project webpage. So, we've done a little bit of I say informal evaluation, one formal study on looking mainly at usability and performance. This is where we need to be right now in the project. I should say we've been at it for about a year, but Jose Ramon, the programmer who's really key, only came last July. So he hasn't been there very long, and so when we look at our Gantt chart about our plans, we're actually ahead of schedule, which never happens on a project. So that's all good, and that's why we've been able to do a little more preliminary evaluation. What happened? I slipped to the back. Sorry about that. Okay, so in terms of usability, I said we've done some usability testing in the organizing information class. Holly White's a doctoral student working on the project, and she's done some testing both semesters, and we've all worked together. We're a very large collaborative team where she has created tasks where students have to search a concept. They've used the concept browser and upload a document, and we give them documents, and then we have a little questionnaire about it that they fill out. And as I said, our advisory board has been really great at giving feedback, and we had them participate in the same usability study that we've been using in the classroom. And then we actually had a virtual meeting where they all gave feedback as well. So in terms of students, and I have students, information, paraprofessionals, you're already dealing with a sort of informed community in the classroom as opposed to scientists who are other users. But we are thinking about both information professionals and scientists. So they have some idea of controlled vocabulary already. They've been taking an organizing information course. And so when I look at the scores, they're positive, and I take them with a grain of salt, and also they're in a class. And they're all told you don't have to participate in this, and we're not going to publish it or anything like that. But I think the scores are probably a little higher than maybe, they would be if they weren't organizing information students. But anyhow, some of the things we've been looking at is understanding of HIVE on a 5-point scale, and of the 32 students, the average was 3.8 on a 5-point scale, so that feels positive to us. Ease of navigation, we're very happy, 4.5 on a 5-point scale. The concept cloud, that one that I said I would love to hear from anybody about it, 3.3. Representing document accurately. So what's happened, one semester we were able to test Smart HIVE, which is the one with the machine learning, and one semester we tested the Simple HIVE, which is just the straight term matching. And we did really much better, 3.3 on a 5-point scale as opposed to 2.0 with the Simple HIVE. So we like that one because we think that the Smart HIVE is really interesting. In terms of the advisory board members, some of the feedback from I don't have all the scaling stuff for them, but the feedback from them, it's interesting. If you go back to the advisory board list, you can go back at some point. I'm going to share my slides with you. But I want to say the more technical people, the things that they wanted to give feedback on were actually different than some of the folks who are more on the front lines in terms of cataloging and information organization, doing it on a day-to-day basis. So the systems technical folks, they kept wanting to ask about integration with systems. Joe Subowski from the Getty Research Institute is on our advisory board, and what he wanted to know is, can I use HIVE? Can I integrate it into EAD finding aids at the time of metadata generation? He's very interested in using it in processing, and same with Bill Nolan from the North Texas Digital Library. Whereas, so Barbara Tillett from the Library of Congress, and Lisa Zoli from USGS, folks, they were, the things that they wanted in terms of usability and improvement were, they wanted to see the term relationships all the time. They wanted to see broader term, narrow term, related term. They wanted things to help them in that respect. We have lots of feedback on color issues, and placements of search boxes and labels. And I'm not a usability person. We have a usability person on our team. But, and it's, ask people to give you feedback on usability, they will. So it's, there are some things that are obviously needing attention. So I do need to have a sip. Something. Said we had a more formal usability study. And students writing this up now for master's research, and we all worked with her, Lena Hong, who actually is the person who did that little video you saw, where she worked with 4 biologists and 5 information professionals and had them in a usability lab, did tracking, did think aloud protocols, used various standard scales about user satisfaction, and so forth, and looked at the time, took time. One thing that was interesting is the average time to search a concept in HIVE, when given, said go search a concept and spend some time on it. Librarians took twice as long, to look at a concept and see if it was relevant for a document as opposed to the scientists. And I have here, that's consistent with researchers in NIEHS. Maybe it's a little apples and oranges in terms of a comparison, but I have some earlier research that I did looking at scientists at the National Institute of Environmental Health Sciences and getting them to create metadata for their web pages, and also having librarians do it. And the librarians took twice as long. And the difference, simple double core, 5 elements, and the difference in quality wasn't that significant. And it was the idea of getting, empowering scientists to do some of the catalog. The average time to go through the automatic processing part, librarians were slightly quicker at doing this uploading and understanding the system. So there's a little more data here. System usability and flow metrics. There are some standard applications there for for measuring things. So on a 20-point scale in terms of enjoyment of working with HIVE, let's see, I should say librarians seem to enjoy it more. And there's other things that they gave feedback on, how they thought this could really help them in their work. I mean, again, it's a small sample. We had 5 librarians, but they wanted to keep experimenting with it. The fact that the scientists were up there to 15.2 on a 20-point scale is, encouraging that we can get the scientists to work with this. Usability. There's a standard system, and some of you may be more usability folks than me, but it's called Standard Usability Scale, 100 points. And the scientists were a little more positive, with an overall score of 79.8, as opposed to the information professionals, which 74.5. Not sure, again, small samples, how much we can say, but fun. So the other area is performance, and this is an area, I guess we're a large team, we divide up stuff in a way a little more engaged in this. And so what have we looked at? Things like specificity and exhaustivity of how well HIVE is performing compared to other systems, relevance, relevant terms, things like that. So there's a system out there that when we started this project, everyone said, well, why don't you just use the NCBO, which is the National Center for Biological Ontologies. It's a registry where scientists are putting ontologies in, and you should just use that. You don't need to build HIVE. Well, it's really a mess. It's great that it's happening. I shouldn't say that it's a complete mess. It's great that scientists are building these, really they're building glorified, sorry, they're not ontologies in the sense of doing automatic reasoning and deduction and so forth, but they are sharing vocabularies amongst themselves, and they're registering them, and they're doing them in OWL, the Web Ontology Language, and OBO, which is another standard, and there's another project called the OBO Foundry. But that project is straight term matching, and we're doing a little bit of the NLP behind the scene and machine learning. And so we did a comparison of our HIVE to the NCBO and measuring some things. We had a small sample, because I said this is still early stuff, but we had 12 abstracts from 12 partner journals. Oh, wait, actually, there were 24 abstracts. That's what's going on. I'm just trying to figure out. 24 abstracts. We took 2 abstracts from each of the 12 journals, pardon me, randomly, and put them through both the HIVE and the NCBO, and ranked on a 1 to 3 scale. We actually had 3 evaluators, so we tried to get a little bit of consistency we instructed them a little bit, what is exhaustivity and what is specificity. They were library science students, so that was okay. So in terms of specificity, with the concepts retrieved, we have an evaluator 1, evaluator 2, evaluator 3, and average. And this is just the exhaustivity, but the specificity ratings, NCBO had a score of 2.0, whereas HIVE was 2.3. So 0.3 is not that much better, but it is better. Exhaustivity, which you're seeing the images for here, that is, or the graphs, that is the NCBO, and that's HIVE. So this blue evaluator seems to always be out of line. But here, it's interesting. You would think that the NCBO might be better because it doesn't have this machine learning behind it, so it would be less likely to knock out terms in terms of exhaustivity, and yet the HIVE actually performed better. And they have some of the same vocabularies, but there are many more vocabularies in the NCBO than we have in HIVE. So we've got 1.7 with 2.2 for the HIVE. So HIVE is performing much better. In terms of relevance, this is really a wide distribution at this point. So the NCBO, in terms of relevance scores, we had a 2.7 to an 8.3, whereas the number of terms that are relevant per test of these 24 abstracts, whereas the relevance for the HIVE range from 3.3 concepts per activity to 10.6. So the HIVE is performing a little higher at the low end and a little higher, maybe even more higher at the high end. Does it make sense to folks? So what I'm saying is the number of terms, the range of the number of terms that are relevant per time a document was uploaded. And so the average number of relevant terms for an NCBO activity was 5.6 and HIVE was 5.8. Not major differences, but as it grows, we'll have to test again. So, 2 more slides. A little bit about the challenges. So, for me, sort of the challenge of building versus doing. You know, I want to dive in there and do the research, but it is part of a demonstration project, so we've got that. We've got to build the HIVE first, which we've been doing, and but we're getting to some preliminary analysis, and I think will lead to more research. I didn't report on all the little experiment kind of things that we're doing here today, or you would probably get really tired. But we have one other area where we've been doing some preliminary research where we're looking at the journal articles as sources for generating metadata, and we pulling from the journal articles the full text, but not the entire text of the journal, from places where data is represented in the journal. So the header of a table, or a little note underneath the table, or every time in the text of the journal article it says table 1, or data such and such. So we're using, again, some kind of natural language processing, and also looking for words like table and graph and so forth. And that's been interesting. And there's research like that in terms of, I say captions with images for indexing, and we're looking at for captions for getting maybe a better source than just the abstract for the data. So a challenge combining many vocabularies during indexing and term matching is difficult, and it's time consuming, and as I said, the simple HIVE is faster, but the smart HIVE is producing better results. So adding in this machine learning component has been a challenge, but a good challenge. Another thing is we've dumbed down the TGN vocabulary. Has many rich relationships in there in terms of geographic relationships, but to interoperate at in the HIVE, we haven't been able to save all the relationships. Now you can make our SCOS version interoperable with a more sophisticated SCOS encoding. You define your relationships. So that's one of the things we have to do. Proof of concept. So we do get asked, why aren't you using the NCBO, especially from scientists? And so we're trying to prove that, you know, that we can't. I don't want to say it's true, that it's better if it's not, but just a challenge. And just large team logistics, getting us all together, defining what's the most important thing to research now, so forth. So some concluding remarks at this point. Vocabularies will enrich access to resources in the Dryad repository, and what the goal there with the data deposition is to support data discovery and data reuse, so the evolutionary biologists can continue their work. And then there's the larger information science, information museum archives community that are dealing with these kinds of challenges. NCBO is great, but it's really not for interdisciplinary humanities collection. So at least what we're doing, maybe we will find ultimately that NCBO answers our needs for Dryad, but what we've constructed in terms of applications and a library of tools could be used in other disciplines, and other vocabularies could be SCOSed and put in there. And what happened there? Oh, I'm not used to this thing. Let's see. I say this is nothing novel because people have spoken about integrating vocabularies for a long time. Again, I think I've repeated myself enough about SCOS and good support now that it allows us to study this. And I'd say Dryad and HIVE they are really real-world applications, and they're using what people refer to as semantic web technologies. And I think we're hearing so much more and more about linked data. I have, I guess, positive days about it and days where I'm doubtful about some aspect of it. But there's a lot to learn from moving forward and finding out things work or don't work. And so I think we're making a contribution. I really believe we're making a contribution in studying these problems and integrating the information, library science, with the scientists and computer scientists all on our team together. So that's the concluding remark. I will share these slides with you, and you have links to the actual HIVE homepage, and from there, right at the top, it says Kyra. There's a URL, and you'll get right to something that looks pretty much like some of the slides I've had. You can upload documents, you can upload abstracts, you can experiment with it, and certainly any of us on the team would love to hear from you. And some links to the Metadata Research Center, the Dryad repository itself, and Nessun. So I can take questions. Yeah.
That's a very interesting talk, actually.
Thank you.
One thing I was curious about, you integrate different vocabulary from different sources.
Mm-hmm.
When you integrate it, do you put them as they appear in original vocabulary, or you reorganize it again in your repository?
So the idea, maybe I haven't been clear, the idea is that HIVE is supposed to reduce the cost of maintaining all these vocabularies. So at the time of indexing, only at the time of indexing, the integration takes place dynamically. But each vocabulary is separate, is maintained separately. It's not a big vocabulary altogether. It's not one vocabulary. It's dynamic integration at the time of indexing.
So in HIVE, the vocabulary still appears as they are in the SCSS or in the
Right. And so with our vocabulary partners, they have SCOS versions. The Library of Congress subject headings is now available in SCOS. The NDII is one of the first vocabularies to SCOS. And the idea is that the cost of maintaining an evolutionary biology vocabulary is just incredible. And even if we were to take what we have now and update it every once in a while, we can't do that. The idea is that you would, every once in a while, once a month, whatever, Library of Congress subject headings comes up with new headings, we would have this interoperation with our vocabulary partners so that we just get the new version of LCSH all the time because it's in SCOS. So it's interoperable. We just get the new version of the NDII and the TGN. So two of our partners already had SCOS vocabularies, which we are using. We made some tweaks. The TGN was in XML, but it wasn't in SCOS. So now we SCOSed it, but we had to dumb it down. But you know what? The Getty wanted it back. They're so excited that somebody put their vocabulary in SCOS, and they're fooling with it now. So what we're hoping is that they'll make a sort of a richer one to interoperate. So it's cutting down on the cost of maintenance of all these vocabularies.
Yeah, because it actually reminds me the UMS project.
Yes.
They have tremendous source from like 100 sources, and
Yeah.
I guess they actually they put the concept together from different sources,
Yes.
and I think they reorganize it into a different way than its original form in the source vocabulary.
Yes. It's a lot of work.
Yeah.
They have a whole.
Years.
Yeah. So it's a much more labor-intensive practice for the UMLS. It's an incredible project. Yeah.
And the second question is for the part of the augmented generation or augmented keyword assignment that consists. I actually very interested about it because one thing I've been thought about is that possible if we let machine provide the automatic result, and then because there are some noise in that, and human let's say clean it later, will that be less cost? If that cost effective mechanism.
So I mean, that's the discussion we have. I showed you the ratings from the students, and they're all positive about it, it's easy to use, this and that, but when you get to, is it relevant? We're down to 2.2, 3.3. So the question is the glass half empty or half full in a way? Is it more work for the professional to come and take that 3.3 kind of okay and add terms and delete terms and so forth? Or it's kind of like copycat logging. Is it easier for them to have just done it themselves and start from scratch? And I don't know that answer, but I do think it was interesting with the 5 professional librarians that they, not their rating results, but watching them, hearing them talk, and thinking about how they could use this in their day-to-day. I think that there is some value, and if we continue to work on the machine learning and so forth. So I'm an optimist right now about it. I think that it's probably still worth it. At least for another year and a half while we have to fund it. So thank you.
Do you know if anybody else has used your model yet, or it's still being?
So it's been really exciting. The LTER, which is the Long-Term Ecological Resources Project, I don't know if you're familiar with it. So that comes out of University of New Mexico, and they've been cataloging ecological data for like 8 years. And they have 50 hubs internationally. Some of you may have heard of EML, Ecological Metadata Language, that's what came out of there. So they want a HIVE. And so we're sharing all our source code with them, and they're going to be experimenting. They're actually working with us a little bit on the Dryad project. There's some testing going on, but they want to experiment with it for the long-term ecological resource data. In addition, I had mentioned with you that Denise Bedford and Marcia Zhang came to visit. Well, Denise is interested in the HIVE for the World Bank because she maintains 8 or 10 different vocabularies there. So I think that's positive stuff. People want to experiment with it. So we'll see. Yeah.
So are your map data that's available to link data?
So are any of our data?
Your mapping sheet vocabulary, is that available to link data?
So, well, depends how you define link data. So because it's all in RDF and SCOS, yes. Our vocabularies fit the link data and model. One of the things that we've been talking about, and we have, LCSH SCOS version and ours are not quite the same, and so that defeats the whole idea of link data, even though we've used theirs. And so that in the coming year is going to be something we need to talk about resolving, because the idea is that there should be, if linked data is true, right? There's only one SCOS or LCSH, and there's only one MBII. And right now, because we're a demonstration project and we're trying to figure out things, there's obviously, we have multiple copies. It's a good question. Yeah, so.
Well, thank you very much for a very wonderful inaugural lecture for us. I think it will inspire us to want to do some more. And we really appreciate you coming up to cold Milwaukee for the North Carolina. Thank you so much.
Thank you so much.